Good morning, Miss E.
Good morning class, I'm Miss Ian. Today I'll be showing you guys the example of solving equations that involve a logarithm. I'll be showing you guys two examples. One example involves logarithm with the same base. Another example involves logarithm with different base. Before I can start with these equations, I will need to go through the rules of logarithms that we will need to use in solving these equations. So rules of logarithm. So when we have logarithm with a x times y, this can be expressed as logarithm x plus logarithm y. And this rule is sometimes mistakenly used by the students. Okay, let me put out the common mistakes here. Okay, when students see logarithm x plus y, some of them will put this as logarithm x plus logarithm y, which is not true. So please note that they are not equal. Okay, the next rule is logarithm x over y, which is x divided by y. We can put this as logarithm x minus logarithm y. And a common mistake that made by students is when they see logarithm x over logarithm y, some of them will put this as logarithm x minus logarithm y, which is not true. Please note that they are not equal. If you compare the left side and the right side, on the left side there's a single logarithm. So when you have single logarithm and its divisions, only we can express this as difference, only we can minus. But if you look at the common mistake, we have two logarithm in these divisions. So for two logarithm in divisions, you can't put this as minus. Please bear that in mind. Only single logarithm you can put as minus. Okay, the next rule is when we have logarithm x to the power of n, we can bring down the power and put as m times logarithm x. And another common mistake made by students is when they see logarithm x to the power of n, they put this as m times logarithm x, which is again wrong. This is not equal. You can see that for the left side, the power m is the power of x. If the power m is the power of x, this power can be brought down. And we compare with the common mistake, this power m is the power of the whole logarithm. So if the power m is the power of the whole thing, logarithm, this power m cannot be brought down. So bear that in mind. Okay, next rule is we also need to know the formula of changing base of the logarithm. So when you have logarithm base a, logarithm b, to change the base, we will need to put logarithm over logarithm, where we put b as the numerator and a as the denominator, and you can change to any base 1. Okay, and then the next rule is when you have logarithm a base a, this is always equals to 1. What I mean is you have logarithm 3 base 3 is 1. You have logarithm 1000 base 1000 is 1, or you can even have logarithm half base half is 1. Okay. So regardless what the a value is, logarithm a base a is always equals to 1. Okay, and students also need to take note that, okay, let's say I have logarithm b base a equals to c. This logarithm value only defined if a is a positive greater than 0. B is also positive, greater than 0. But C can be any value. C is all real value. C is all real value. So bear in mind that logarithm of a negative value is undefined. Okay, next I'm going to show you the questions, the equations I'm going to solve. This is the equation I'm going to solve. Okay, you can see that in these equations, the base is not stated. I think everybody should know that for a logarithm, when the base is not stated, it is base 10. It is base 10. So all this logarithm has the same base 10. So what we need to do is we have to think of a way, since they have the same base, we have to think of a way to combine all this logarithm. The idea is, okay, let me show you the formula. So we can use the first two rules to combine them. So when you have logarithm x plus logarithm y, we can combine this as a single logarithm and we put them as times. Or when you have logarithm x minus logarithm y, these can be expressed as a single logarithm, which is dy. So remember, when you have logarithm plus logarithm or logarithm minus logarithm, you can always combine them. Okay, since we want, and you can see that in these equations, the left side can be combined. How about the right side? Right side, you can see one logarithm log 2. So what am I going to do is, I'm going to keep all the logarithm together at one side. I'm going to bring over this log 2. Then we will have logarithm 3x minus 2 plus logarithm x plus 1 plus logarithm 2 equals to 2. I put all this logarithm together so that all this logarithm can be combined as a single logarithm. So I'm going to put logarithm, and this is base 10. So we have 2. I'm going to put this as 2 here. And we have 3x minus 2. So I'm going to put 3x minus 2. And we have x plus 1. So this is how we can combine all these logarithm as one. We make them times because it's additions of logarithm. So once we can combine all this logarithm as a single logarithm, we can remove this by changing this logarithm form to index form. So we know that 10 to the power of 2 equals to this. Then we will have 2 times 3x minus 2 times x plus 1 equals to 10 to the power of 2. And to simplify these equations, I prefer to have a smaller number, so I will bring over 2. What I mean is I'm going to use 100 divided by 2. Okay, and also we need to expand this. If we expand this, we will have 3x squared plus x minus 2, and the right side will become 50. 100 divided by 2 is 50. And this is actually a quadratic equation that can be arranged as 3x squared plus x minus 52 equals to 0. And we can solve these equations by doing factorizations. Then we will have 3x plus 13 and x minus 4. So in the end, our solution is x equals to negative 13 over 3, or x equals to 4. So student, please bear in mind that whenever you solve a logarithm equation, checking answer is very important. What I mean by checking answer is, after finding this x value, we need to substitute this x value back to all this logarithm. So since we have found x equals to negative 13 over 3, I'm going to substitute this value into logarithm 3x minus 2. Then we will have 3 times negative 13 over 3 minus 2. And if you try to find this value in the bracket, we have negative 15. As I told you guys earlier, logarithm of a negative value is undefined. So in this situation, x equals to negative 13 over 3 is not a solution. Then we have to check x equals to 4. So when x equals to 4, we have logarithm 3 times 4 minus 2, which is logarithm 10, which is acceptable. We have a logarithm of positive value, and we need to check the other one as well, which is logarithm x plus 1. Then we will have logarithm 4 plus 1, which is logarithm 5, which is also acceptable. So in this equation, there will be only one solution, which is x equals to 4. Okay, next, I'm going to show you another example that involves logarithm with different base. Okay, this is the equations. So as you can see from here, the base involved is base 3 and base x. So you can either change base 3 to base x or change base x to base 3. No matter which base you change to, so long your working is done correctly, you definitely get the same answer. So maybe I change base x to base 3, I change the second logarithm. So for the first logarithm, I will put this as log x base 3. And we have to apply the formula of changing base. Remember the formula I showed you just now? For changing base, you have to put log divided by log. 3 you put on top as numerator, x you put as the bottom. And what base do we change to? Of course, the same base as the other logarithm, which is base 3. So I'm going to put 3 here and equals to 4. And students, please take note that whenever you see divisions for logarithm, it's not always true to put this as subtractions. It's not true to put this as log 3 minus log x. This is only true when we have, let me show you an example here. When we have log 3 over x, only we can put this as log 3 minus log x. Only this is true. So when we have logarithm divided by logarithm, we cannot express this as difference. We cannot put them as minus. So this is wrong. So although we cannot put them as minus, that doesn't mean that we cannot do anything on this. Remember guys that when we have log 3 base 3 is 1. So I'm going to simplify this as 1 over logarithm x equals to 4. You might be thinking to use the same idea like how I solved the equation example 1, where we combine all the logarithm as one logarithm, and then from there we can remove the logarithm. But I can show you in the next few steps that this working doesn't work for these equations. So for this second logarithm, which is 1 over log x, I'm going to put this as logarithm x to the power of -1 is to 4. And please take note that this power, some student might be thinking to bring down this power and put as negative log x, which is wrong. Remember I told you guys earlier, this power can only be brought down for this power -1 can only be brought down if this -1 is the power for x, power of x, but not the power of the whole thing logarithm. So only this can be brought down. So since in these equations, the power -1 is actually the power of the whole thing logarithm, so it cannot be brought down. So it seems like we cannot use the way like how we solve the equation in example 1, because we cannot bring down the power, we cannot combine them. In these situations, we have to use substitutions. So next, I will let y be equals to log x. Then these equations will become y minus 12 times 1 over y equals to 4. And I will simplify these equations by multiplying the whole thing by y to get rid of the denominator. Then we will have y squared minus 12 equals to 4y, which is a quadratic equations. Then we will have y squared minus 4y minus 12 equals to 0, and we can solve this by factorizations. Y minus 6y plus 2 equals to 0. Then we will have y equals to 6 or y equals to -2. And of course, we have to move on to find x because we are solving for x in these equations. Since we let y be equal to log x, and we found y equal to 6, which means log x equal to 6, and log x equals to -2. And we can find the x value by changing this to index. So we have x equals to 3 to the power of 6. So x equals to 729. And as for the other value of logarithm x, some students might be thinking this cannot be solved. They will just put no solution. So this actually can still be solved. This logarithm only not defined when these two are negative. But since they are not negative, we have to continue to solve. So 3 to the power of -2 equals to x. Then we have x equals to 1 over 9. So in this equation, there will be two solutions. So you can see, you can compare these two equations in these two examples. When we have a different base, equation that involves different base, first of all, we need to change the base. And then after that, after simplifying only, we realize that the power cannot be brought down, and we cannot combine this. When the logarithm cannot be combined, you have to use substitutions. Whereas if you look at the equations I show you guys in example 1, all these logarithm can be combined. So we will combine them whenever possible. So I hope this video has given you a better understanding about solutions to equations that involve logarithms. If there's any part of the video that you have that you don't understand, that you have problem with, you may leave your comments. And please share this video with your friends if you found this useful. So thanks for watching. See you next time.